Hello guys. So this video is for lab number 7. So for this lab, just give me 1 second. Let me So actually this lab is a practice on decoders and multiplexers. So before you do this lab, you have to study these two topics. I already explained them in the lectures. So here in this lab, first I'm explaining to you what is decoder and what it is doing. So it's already in the slide. So you may not even need this part if you already understand the slides. And then, so here in this lab, we're not gonna design decoder. No, there is some chips that have already decoder. So the chip itself has a decoder. And this is actually this is chip 138. This one has a decoder. This decoder is 3 to 8. So 3 inputs and 8 outputs, as you will see right now. As I told you in previous labs, you need to click on the link link here, so that you can, once you do that, you will find the data sheet for this chip. Okay, so for sure you need to read this data sheet. Also, if you want to know more information about decoders, you can click on the hyperlink here in this word. But the slide should be enough. If you understand the slides, if you miss lectures, already I posted all lectures are recorded online. You can just use them. So for this chip, if you go to the data sheet, you will find something like that for this chip. So as you see here, for this chip, we have 3 selectors, which is pin number 1, 2, and 3. So the first 3 pins are for selection. For the outputs, 8 outputs, the 8 outputs are actually from here. As you see, Y0 here is pin number 15, 14, 13, 12, 11, 10, and 9. Okay. You need to connect pin number 16 to VCC, which is 5 volts. You need to connect pin number 8 to the ground. Okay, and now you have you have this one as well. I forgot this one because you have eight outputs. So this is Y0. Y is the output. So you have Y0, Y1, Y2 until Y7 is here. Okay. So one more thing here, as I told you in the slides, when you see bubble this way, that means the output are active low. Okay, I will tell you shortly what this means, but I told you in the lecture. In order to use this chip, you have three pins for enable, actually, for enable. So in order to enable this chip, number 1, okay, give me just 1 second here. You have for this pin, which pin number 6 here, there is no bubble, which means it is active high. So you need to put 1 here to enable the chip. Is this one is enough? No, the enable actually here is not only 1 pin, but it is 3, as you see here. But here you can see there are bubbles here. You can see there is a dash here. So this means these 2 are active low. That means in order to enable this chip, you have to put here 0, 0, and then you have to put here 1. If any one of them is different, it's not going to be enabled. Okay. So for example, this one, so in order to enable the chip, you have to enable these 3 pins. For example, if this one is 0, okay, this is okay. Okay, if I put here 0, so it's not going to be enabled. You have to enable all of them. And this is actually, if you go to the data sheet, you will see actually this is exactly explained in the truth table here. So in the truth table here, as shown here, for some reason, I'm not sure why this truth table does not have, let me go back here. Is it G1 and G2A and G2B? Okay. So for some reason, so I think G2 here means A and B. Both are the same. It looks to me like that. And this is G1. Okay. So here, this part, it is actually disabled. So actually what we are seeing here, if you just make this one high, that's exactly what I told you. If you make this one high, so actually is gonna be disabled. Okay, if you make this one low, which is okay, so sorry, low, because this one is active low as I told you. So regardless of what you put here, it is disabled. So in other words, as I just, so this case it is disabled. So when this chip is disabled, you can see all outputs are high, regardless or the values of EBC. Okay, so one more thing here is, and so that means if you want to enable the chip, which is actually this part, you have to enable the 3 pins, as I told you. So G1 has to be high, and G2 is 2 parts, as I told you, G2A and G2B. These two should be actually low, as you see here. So that means it is enabled. If it is enabled, so it's gonna work as a normal decoder. Okay, so here in normal decoder, as you see here, we have here 0 0 0. Okay, the 3 pins are here, ABC here. Okay, so that means if you see here L0, Y0 is high, is low, and everyone else is high. Okay, this is actually, let me see here, this is, if you go to the slides, that's what I told you. When the outputs of the decoder are active low, that means the one that is low, low here means 0, by the way. So every H means 1, every L here means 0. Okay, so low here, so that means the one that is low is actually is reflecting the number we have here. Okay, so another issue here, you can see when this one is high, okay, so it's going to become like 1 0 0. Okay, so one, which is number 1. That's why you see Y1 here is here. Okay, so be careful here, because this is something always is going to confuse you, but you have to be careful. Here, A actually is the least significant, C is the most significant. Okay, so sometimes we do it the other way. Sometimes we say ABC, where A is the least significant. But again, the way it is done is here, A is the most significant, but the way it is done here is actually, as you see here, A is actually the least significant. So anyway, same thing here. If all of them are high, that means the number is 1 1 1, which is 7. So you can see Y7 is low, everyone else is high. Okay. So again, if you go to the lecture, I told you we have a different types of decoders. These decoders don't have these bubbles. Okay, in this case, we call them active high. Okay, that means everything here will be flipped. Okay, so actually normally all of them are low, except the one that's selected becomes high. Okay. Okay, so actually, so this is for the decoder. For the multiplexer here, I'm explaining what is multiplexer. Also, I'm explaining how can use the multiplexer to implement a function, as I explained in the lecture. Okay, so if you understand the lecture, you don't need this part. I already explained what is multiplexer in the lecture. And now, this is the one we are going to use, 153. Again, you need to, if you click on this one, you will see the data sheet. So this is actually 4-to-1 multiplexer. As I told you in the lecture, here the input are 4, and because the input are 4, so we need actually 2 selectors here. 2, because the relation is 2, and this should be 2 to the power of n. And always in case of decoder, in case of multiplexer, we have only 1 output all the time. Okay. So quickly, as I said in the lecture, based on the number you put here, the output will be similar to any one of this one here. So if I put here number 0 0, so actually the output will be similar to pin 0. Okay, if the output here is 1 1, which is number 3, so the output will be similar to number 3, and so on. Okay. So let's look at the data. Yeah, so actually this is the chip. Inside this chip, actually there are 2 decoders, not 1. Every decoder, every one of them is 4-to-1. Okay, for input and so here, so they are 2 separate. So you can actually, in this lab we need only 1 of them because they are 2 separate. Okay, so for the first decoder, this is the output here is pin number 7, and for the second decoder, the output here pin number 9. Again, they are separate. Okay, For the first decoder here, you can see this is input 0, input 1, input 2, input 3. And this is the enable of the first decoder. This multiplexer. This is the enable of this multiplexer, okay? And you again, every time you see this bubble, it means it's active low. So that means if you want to enable this multiplexer, so you have to put here 0, okay? Same thing for the other one here. So again, this is pin number 10 here is actually input number 0, input number 1, input number 2, input number 3 for the second decoder. And again, we have one enable here as well. Okay. So in this lab, we're going to use only one of them. So it's up to you. You can take this one or this one. It doesn't matter. Okay. This is the truth table. This is, so as you see here in the truth table, as I told you, we have enable here. We have enable and we have one output. We have 4 inputs and we have selectors, 2 selectors. Okay. How it works is very simple. Because this is active low, if the enable here is active low. So if I put here high in the enable, that means it is disabled. Okay. Because it's active low. That's why you see here in this part, it is disabled. When it is disabled, so the output is low all the time, regardless of anything, regardless of what you put here, regardless of what you put here, always the output is low because it is disabled. It's not working. Okay. Now, if you, in this part here, it is enabled. Why? Because you see here, I put low here in the enable. Okay. Now, based on whatever you select here, okay, so here it is 0, 0 because it is 0, 0. So I'm going to select pin 0. Okay. So again, you need to notice here S1 is actually the least significant bit and S0 is the most significant bit. Okay. That's how it was made. So actually, yeah, this is S1 is here and we have S0 is here. Okay. S node and which are actually here you see in this chip pin number 2 and pin number 14. Okay. So you need to be careful here. Why? Because when you design or during the lab, when the input is 0, 0, okay, so, or when, for example, if the input is number 1, so which is 0, 1, okay, so this one, should I put it here? Which one is the most significant and which one is least significant? Is that okay? So you actually want to connect number 1, you want to connect the number 1 to the output. That's okay. To do that, I have to put number 1 in the selector, but you need to know, otherwise it's not going to work correctly. Okay. So as I told you here, S1 actually is the least significant. So if it is 0, 0, that means number 0. So actually here you can see if pin number 0 is low, the output will be low, similar to pin 0. Okay. Same thing for the other ones here. So here we have all possible cases. So for example here, let me see here. Yeah. So here, yeah. So here it's actually, here what I'm saying, if you see here it's the same case, right? So low, 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 low. That means it's 0, 0. So I selected pin number 0. That's why if you see here, when pin number 0 low, the output is low. When it is high, the output is high. Okay. So I actually connect pin number 0 or input 0 to the output. Same thing in the second case. Okay, let's see the second case. The second case is here, which is actually when the selector is, as you see here, the selector is actually 1, 0, 1 and 0. Okay. So when it is 1 and 0, actually I made a mistake. I'm really sorry. It's not from me actually. The data sheet is really terrible. So actually it has to be this way. So it seems to me S0 is the least significant, S1 is the most significant. Okay. The way they made this table, it's confusing. But again, you can guess it from here. So once I put 1 here in S0 and 0 here in S1, okay. So this actually number 1. Because it's number 1, that means this is the least significant and this one is the most. How did you know it's number 1? Yeah, because you can see here, they are going to connect the number 1 to the output. Is that okay? So I'm really sorry about that. But again, I think the people who made this data sheet, it's really confusing. It would be much better if you make S1 and S0, okay, and this one least significant, this one is the most significant, okay, but they switch it. That's okay. So anyway, so now you have here in the most significant, I put 1, the least significant, I put 0. Okay. So that means this is number 2. So I'm going to connect to number 2. You see here, I'm going to connect the number 2 to the output. Same thing in case of high, high. High and high, that means it's 1 and 1, which is actually number 3. Okay. So what you have to do here in this lab is, so you already have one chip for a decoder, for 3 to 8 decoder. I explained it. And also you have another chip for 4 to 1 multiplexer. Okay. Actually, this chip has two multiplexer. We're going to use only one of them. Okay, so what we're going to do here is, I also explained in the lectures how can we use decoder to implement, and same thing for multiplexers, how can you use them to implement some functions. Okay, so here, for example, here in the first part here, this tab has two parts, one part for the decoder and the other part for the multiplexer. For the decoder, I give you this function here, and all what I'm telling you, I want to implement this function using the decoder. Okay, using 3 to 8 decoders. That's very easy because it has 3 inputs here, and this is 3 to 8. Okay, so if you go to the lecture, as I told you, when you have this 3 inputs here, which corresponding to the function, you are going to have here 8 outputs. So 8 outputs, actually, they are going to give you the min terms. And then all what you have to do, you have to use OR gate, as I told you here in the lecture. So you remember, you need to study this slide. You need to see how I explained it in the lecture. This is exactly similar to this one. However, our decoder is not like this one. Okay, our decoder is different because this one, there is no bubble here. It means this one active. This one is actually active high. Okay, so you should not use this one. I also explained here in case, yeah, this one. This is actually our decoder. Okay, our decoder is actually active low. Okay, so all what you have to do, as I explained here, is you need to see what min terms you have. In our case here, these are the min terms we have: M0, M1, M2, M4, and M6. And then you have to use NAND. You have to use NAND as I used here. Okay, that's it. And then, yeah, so here, this is the first part. In the second part, I have a function. This function, it's called the G function. This function actually has 4 inputs, as you see here. Okay, and this is min terms of the function. And then I'm asking you to use multiplexer 4 to 1 to implement this function. Okay, I just want to remind you what I explained in the lecture. Again, you can go to the lecture. What I explained here in this example, this is the least efficient way, okay, or the very naive way. I'm going to tell you why right now. So actually, as you see here, is the what's happening here is here. I'm gonna use the function has three inputs, 3 inputs here. So I'm gonna use 3 to 8 multiplexer. Okay. So this is one way to do it. Okay, 3 to 8. So all what I did here, this is the 3 here, and for every input here, I put the value we have here. So if the input 0, 0, 0, the output has to be 0. That's why I'm gonna put here 0, because I know this is how the multiplexer works. The multiplexer is gonna connect the output here to this pin. So if the input is 0, 0, what the function is telling you, what is the output? It is 0. So that's why I have to put 0 here. Let's have another example. If you look at this example here, which 1, 2, 4. So this is in case of number 4, 0, 1, 2, 3, 4. So in this case, I have to put 1. So that when this one 1, 0, 0, okay, sorry, the output is going to be connected here and connected to 1. Okay. And then I told you we can do a trick. There is a trick, and using this trick, I can implement the same function, but instead of using 3 to 8, actually I can use 2 to 4. So smaller multiplexer. How I made it is this. I'm just repeating what I said in the lecture because that's what we need right now. Okay. So the way I explained it, as you see here, what I said. Now this one is actually, I'm sorry, I think I made a mistake. This one should not, I'm sorry, it's not 2 to 4. 2 to 4 is in decoder. Okay, this one 4 to 1. Okay, so instead of using, I'm sorry, again, I'm really sorry. I confused between decoder and, but it's crystal clear. So actually here it should be 8 to 1. Okay, so instead of using 8 to 1, it's crystal clear. Why? Because in case of multiplexer, as always the output is 1. You don't need even to think about it. So 8 to 1. So here, that's what I did here, 8 to 1. So now I'm going to do a trick, as you will see, as I explained in the lecture. Instead of using 8 to 1, I'm going to use a smaller one, which is 4 to 1. Okay. So let's see what I did. What I did here, these are all possible cases. Okay. So what I did, I just took, because when this one 4 to 1, so I have two selectors. But the input here have 3 inputs. You got what I'm saying? So what I did here, I have three selectors and I have 3 inputs. So I just connected the inputs here. That's it. Okay. But here, the number of inputs here is equal to the number is one less than the number of inputs here. Okay. So what I'm gonna do here is I'm gonna take only X and Y. Okay. I'm gonna connect here X and Y. Okay. And then I'm gonna try to use the remaining input here as I put it here. I'm gonna tell you exactly what I mean. What I mean is, look here. Again, that's exactly what I explained. I'm just repeating it because we need it here. So what I were doing here we have 2 cases of 0, 0. Okay. So in these 2 cases, if here is connected here. Okay. So now the question is that, what should I put here? What I should have put here? Okay. So all what I have to do is I have to get a function between f and z. Okay. So you can see here in these 2 cases, okay, f is always equal to z. Okay. So I'm gonna just put z here. I'm gonna say f is equal to z. That's it. Okay. Let's look at the second case here. In the second case, yeah, so these 2 cases here, again, the selector, these two are connected to the selector. So this is case number 1. Case number 1, so here, actually, this one is connected here. Okay. So what should I put here? So that I'm gonna get this one in this case, I'm gonna get one in this case. Okay, again, I'm gonna get a relation between f and z. So you can look here, the relation if f equals z prime, because when this one is 0, here it's 1, 1, 0. That's why I put here z prime. Is that okay? Same thing for the other one. So if you look at this one, which is number 2, so this one here actually connected to number 2 here. So in this case, it is 0, no matter what. Okay. So regardless of the value of z, it is 0. That's why I'm gonna all the time it is 0. Okay. Or in these 2 cases, it is 0. Same thing for number 3. If you look here in number 3, okay, so it is it's 1 no matter what. Okay. So again, this is not what we are gonna do. It's the idea is pretty close, but it's not this one. Why? Because this example I have here, I have two input in the selector, as you see here, but I have here 3, right? I have 3. So what we're gonna do right now, I'm gonna use the same multiplexer. I have 2 input, but here I'm gonna have 4 inputs. 4 inputs. Okay. So in this case, this function, the relation here, it will be more complicated because this relation is going to be a relation in 2 inputs, not only 1. Okay. So let me explain what I want to see here. So for example, this is the truth table is this way. Okay. So here I have 4 inputs. My multiplexer has only 2 selectors. Okay. That means this here, this is these 4 cases. In these 4 cases, because this is here, we have WX. Is that okay? And then I have 0, I have 1, I have number 2, number 3. Okay, 1, 0. That's okay. And then I have the output. So in these 4 cases, the input here is connected to number 0. Okay. And then if you look in these 4 cases, so this is number 1, the output here is connected to number 1. Okay, because this is number 1. X and Y are the selector. In these 4 cases, here, these 4 cases, actually, the output is connected to number 2. In the last 4 cases, the output is connected to number 3. Okay. So now, all what you have to do is that I need to find when the input is 0. Okay, let me clear everything first. Yeah. So let's take the first case here. Okay. When the input is 0. So in this case, I know, so I have here the selectors are W and X. I know the output here is connected to pin number 0. Okay, that's what I know. So similar to what I did before, but what I did before here, it was simple. Why it was simple? Because if I got the relation between F and Z, Z is only one variable, so it should be easy. right? So here it's a little bit more complicated because I need to get the relation between f and y and z. You got what I'm saying? So here, if I go to the here in the example here, I give you here the main terms. Okay, so you have to do that I give you the main terms. Okay, so here in the function you have to put you have to put the f here. Okay, so for example you have 0 1 4. Okay, let me put, for example, this is 0, so 0 should be 1. Okay, 0 and what? 1 and 4. Okay, so here 1. Okay, this one should be 0 0 and then 4 and so on. You can complete it this way. Okay, so all what you have to do now, I want to get relation between f and x and y, whatever the relation is, and then I'm going to put the function. I'm going to put it here. Okay, so that means, for example, for sure you can use maps to simplify it, or you can whatever. So try to simplify it. Okay, the very simple way, if I don't use simplification, for sure, but it's recommended in this lab to do simplification. Okay, so but for example, the simple way, I'm gonna make it like sum of product. So in this case, so actually f is equal to xy, sorry, y, so y prime z prime. Yeah, this is case here, y prime z prime, and then if you look at this case here, it's actually or y prime z. Okay, yeah. So this one here. Let me see here again. So this one, yes, y prime z prime. This one actually y prime z. Okay. Okay, so actually it looks like something like that. Okay, so it's going to be here y prime z prime, and then here is going to be y prime z. Okay, for these two. Okay, again I'm going to explain one case, but you have to repeat what I did right here. So I'm gonna do only one input, but remember we have 4 inputs. Okay, so I'm going to explain one case, and then you have to do the other cases. Okay, so this case, so whatever the function, I'm going to explain how can you get a function here, and then you have to put it here. Okay, but the same thing, you have to do it here, here, here. Okay, so this is a function I get, but I can simplify it because it's only 2 inputs. Maybe I don't need maps, or again, whatever you like. But if you want to use maps, it's okay. But usually for 2 inputs, maybe maps, maybe it's easier to do it to our algebra manipulation is not difficult. But anyway, if you want to do math, if you want to do, that's okay. So for example, here, what I do here, see, this one should equal. Okay, I can do some simplification here. If I take y prime as common here, okay, I just want to make sure it's correct. Yeah, because here we have 1 here, 1 here, 0 0. So this one y prime z prime or y prime z. Okay, so I can take the y prime common, so this one becomes z prime or z. You know, z prime or z is actually 1, so it becomes y prime and 1, which is equal to y prime. So that's it. That's done. So all what you have to put here is just y prime. That's it. Okay. For the other ones, I don't know. I didn't calculate them. You need to calculate them, but maybe you need and. You need or, so whatever is the relation you get. So I calculate the first one. It was very trivial. It's just y prime. That's it. So here f is equal to f is equal to y prime in this case. Okay. Any questions? Okay. So I shouldn't ask any question because I'm recording a video, but every time I explain, it's just a habit to say any question. Anyway, so just you need to do everything for the other one, and then you implement. I think that's most of it. So in the first part here, part 1, I'm asking you to implement the first function here using decoder, and then you need to test it. You need to see. Test here means you have to exhaustive test. That means you have to try all possible cases, and then if you can get the same function given to you here, if your implementation is giving this function, that means, you know what it means? It means when the input is 0, I get 1. When the input is 1, number 1, I get 1. When the input is number 4, I get 1. In the input number 6, I get 1. Any other input, I get 0. If this is the case, the implementation is correct. Okay. So here, yeah, so here just I ask you to implement it and make sure it's correct. Same thing for part 2. So here in part 2, it's the same thing for the function g, okay? Using the multiplexer, you need to test it, make sure it's working. The last thing I have here is actually, you have two simple question. Yeah, I forgot to tell you, for each case, I'm asking you to measure the propagation delay, worst propagation delay. And you have to compare in the pre-lab, you have also to estimate the propagation delay. How can you estimate the propagation delay? You need to read the, as we did in the previous labs, you need to read the data sheet, right? So in the data sheet, you can, in the data sheet, you can see what is the delay, and then you compare it with the delay you are measuring here, okay? So you try to find the worst case, okay? Anyway, so here in this lab, you have two questions. The second question I'm asking you here, why the delay, why the delay you estimated, is that the same or exactly similar to what you measured or different? Usually it should be different. It's very difficult to get exactly the same thing. But if the amount of error is small, it should be okay. The second thing here we have, I'm asking you to, can you use, if we have 2 to 4 decoders, okay, so we have to decoder 2 to 4, we have 2 of them, okay? How can you create a 3 to 8 decoder out of 2 to 4 decoder, okay? Anyway, actually, this is already, if you go to the slide, and I'm going to explain it in the lecture, but it's already explained here. How can you use? You need to think. I'm gonna explain it in the lecture. Given 2 to 4 decoders, 2 of them, I was able to create here a decoder that is 3 to 8. So anyway, think about it. Read the slide. Try to think how I made it. So the way I made it, as you see here, for 3 to 8. Yeah, 3 to 8. So I should have here 3 inputs, X, Y, Z, right? As you see here, 3 input. I call them E, X, Y, 3 input. And then we have 8 outputs. And then based on the value here, if the inputs are 0, so the output number 0 is 1, everything is 0. When the output is number 7, so pin number 7 is 1, everything else is 0. So, okay. So actually here, the first 2 ones here, X and Y, are going to be connected to the 2 decoders, as you see here, 2 decoders. And then the trick here, I'm going to explain it in the lecture, but I can explain now quickly. So the trick here is, this one, I'm going to connect it, yeah, the enable here. This is the enable. So I'm going to connect this one to the enable directly, and then I'm going to put inverter to connect it here. So what it means? It means when the E is 1, this one is enabled, but this one is disabled. Why? Because the inverter here is going to make here 0. Okay, and this is active high. So this one is enabled, this one is disabled. But if I put here 0, okay, so this one is disabled because the input here is 0, but this one is enabled. Okay, so again, because of this because of this inverter, only one of them. That means in this part here, 0, 0, 0, we're actually using the first one here. Okay, but here in 1, 1, 1, 1, I'm enabling the second one. So the second one is working. Is that okay? And then based on the selector here, I'm going to select 1 out of 4 here, and then I'm going to select 1 out of 4 here. Okay, based here in the second one here. Okay. Anyway, that's the end of it. Okay, thanks.